All right, today we're going to look at section 9.9 was looking at an introduction to trigonometry. We're going to look at three trig functions here with the sine, the cosine, and the tangent. And you're going to need to remember the sine being equal to the leg opposite of whatever angle we are talking about over the hypotenuse side, so we have to be talking about right triangles in all of these cases. The cosine being equal to the leg adjacent to whatever angle we are talking about over the hypotenuse, and then the tangent being equal to the leg opposite divided by the leg adjacent. And there is a story about Mr. Chief Sokotoa that helps to remember, so you guys can go ahead and read this. Take a moment to pause it and read it. But it ends with, for that behavior, he was named Chief Sokotoa. And if we remember Sokotoa, this will be how we will remember all of our trig functions and ratios. So we need to remember, and I like to write Sokotoa. Sokotoa. So the sine is equal to the opposite over the hypotenuse. The cosine is equal to the adjacent over the hypotenuse. And the tangent is equal to the opposite over the adjacent. So if I'm looking at angle D for all of these, for sine, what is the opposite side to D, which is 5, over the hypotenuse side, which is 13. For cosine, look at adjacent, which is 12, over, and then 13. And then for the tangent, we're looking at opposite over adjacent, which is 5 over 12. So looking at these triangles here, so again, the letter here, M, L, Z, X, it's telling you which one to do, so, or which angle to look at. So for the first one here, we're looking at sine of angle M. So looking at M, and let me write our Sokotoa again. So looking at M, we're looking at the opposite over the hypotenuse, which is going to be 16 over 34, which is 8 over 17. For 2, we're looking at cosine of Z. So looking at Z, the adjacent leg to Z is 12, and then the hypotenuse is 20, which reduces to 3/5. And then when I'm looking at the tangent of L, so looking at L, the opposite over adjacent would be 30 over 16, which reduces to 15 over 8. So go ahead and pause and see if you can solve the last three here. Sine of x opposite over hypotenuse is 12 over 20, which is 3/5. Cosine of L adjacent over hypotenuse, 8 over 17. And lastly, the tangent of Z, which is 16 over 12, or 4/3. For the next four, we're going to be given the ratio and the angle that we are looking at, and we need to recognize which trig ratio, which one it represents. So when I'm looking at angle G, and then 9 over 41, that is opposite over hypotenuse, so that we are looking at the sine. For number 8, we're looking at angle H, and 40 over 9 is the opposite, is 40, and the adjacent is 9, which is the tangent. When I'm looking at angle H, and 40 over 41 is opposite over hypotenuse, which is the sine. And for the last one, angle H, and then adjacent is the 9 side over the hypotenuse, so that is the cosine. We can use these to also solve for values. We have a proportion here again. Make sure on your calculators that your mode is in degree mode. We are taking sine, cosine, tangent of 20 degrees in a triangle or 37 degrees in a triangle. So this is just like having sine of 20 over 1. So if I wanted to find the value for A, I would cross multiply and get 15 sine of 20 equals A. So type in sine of 20 times 15 on your calculator, and you will get A is about, we'll round to the 3 decimal places, 5.13. For B, cross multiply, and we'll get B is equal to 30 times cosine of 37. And to 3 decimal places, B is about 23.959. Go ahead and pause and see if you can solve for C and D. So C was going to equal 5 times tangent of 64. Which is about 10.252. When you cross multiply for D, you're going to get D times sine of 32 equals 12. So we're going to need to divide both sides by sine of 32. So D is going to equal 12 divided by sine of 32. And D will be about 22.645. For number 12, we need to actually set up the trig function as well. So in this case, I am looking for A first. I have angle 60, and then the hypotenuse 12. So when I'm looking at this one, I need to take the fact that I have the angle 60, and then I'm looking for opposite. Remember SOHCAHTOA here. I am looking at opposite and then 12. So that would be the sine of 60 equals A over 12. So then I can cross multiply and solve. And I also know that this is a special right triangle, and so I could get A as 6 root 3. For C, this is another special right triangle with 45, so it'll be 8, 8, and 8 root 2. I can just stop there. For D, again, I have 15, and I have opposite, and I'm looking for hypotenuse. So sine is the function I need to use. Sine of 15 equals 25 over D. When I cross multiply, I get D times the sine of 15 equals 25. So D would equal 25 divided by sine of 15. And you can get that decimal. And for E, I have 12 degrees. And I'm looking for the opposite and then the adjacent. So for E, it would be tangent of 12 equals E over 40. And when I cross multiply, I get E equals 40 times tangent of 12. Which means E is about 8.502. We could do the same thing with a diagram here. Flagpole is held upright by 30 meters. If the wire makes a 25 degree, how high is the flagpole? So I'm looking for X, which means with the angle it's opposite and hypotenuse. So sine of 25 equals X over 30. Cross multiply and I get X equals 30 sine of 25. Which means that the height is about 12.679. And then for the last problem, find the cosine of angle C. What I need to recognize first here is that I have an isosceles triangle. And when I draw in the altitude of an isosceles triangle, it's also the median, so it's 5 and 5. I create a right triangle. 5, 12, 13. And so when I'm looking at the cosine of angle C, looking in my right triangle, would equal the adjacent side 5 over the hypotenuse 13. And that is the end of the 9-9 notes.